I wanted to show you guys how to create the table on the Freefall Lab. So you guys made your videos like this one right here. And I'm going to show you guys how you're going to collect the data from this. So if you have your video on your phone or if you have your video on your MacBook or your laptop, I'll show you guys how you can get that data and organize it. So you'll want to open up your video either on your phone or on your MacBook and then just trim right here. This will allow you to look at the specific time. So right here, and you can see the seconds, the milliseconds as the object is moving. So you'll have to locate the point on the video where the student is barely dropping the ball. So they're barely letting go of it. And you can see that right there. So at this point, this is going to be your starting point. So let's say right here at 0.87. So you'll want to copy this chart and put it on a spreadsheet. So we'll just do that. You're going to do this for the two objects that you guys released, right? So for the first object, I'm going to make this table, and then you guys can make it for the other one as well. So what the data that we're going to focus on right now is just the distance that the ball is falling. Every once in a while, we're going to pause the video, or we're just going to move the video and then measure the distance that the ball is traveling downwards. And then we're just going to write down what time it is, right, at that specific moment. So we're only going to fill out these two right here. And then we can use this data to calculate velocity, acceleration, and then we can fill out this other stuff with the mass, the force, the acceleration due to gravity. So right here, the distance traveled at this particular moment, the ball has not traveled any distance yet because I think this is Jacqueline right here, and she's barely letting go of the ball. So there's no distance traveled, right? So right here, there's 0 distance traveled, and the time, so we're going to start off at 0.87. So we're just going to put 0.87 right here. That's going to be our starting point. And then we just move this just a bit. So as the ball keeps moving, it's moving downwards, downwards. You guys can pause it like really wherever you want. So it doesn't matter. And the more you pause it, the better, the more data you'll get. So I only put spaces like for 10 pieces of data. But if you want to put more, you can put more. So at this point, the ball has barely fallen from the 600 mark to the 550 mark. That's only 50 centimeters that the ball has gone down. And the time is 1.11. So at 1.11, right here, 1.11, the ball has barely moved 50 centimeters, which is 0.5 in meters, right? So those 50 centimeters are 0.50 meters. Then we'll keep doing the same thing. So right here, I keep moving the video, let the ball fall a little bit. So let's say right here, it's now at the 450 mark. And then that means that the ball has gone down 150 centimeters. So it's gone down 150 centimeters, which if we convert it to meters would be 1.50 meters. The time at this position will be around 1.34. So we put 1.34. Then we keep on doing this until the ball hits the ground, right? In this particular case, you might notice that the sheet of paper ends right here. We would need to take into account this space that they're not taking into account. So this is around 50 centimeters that we need to take into account. So we'll probably have to add that to the total. So this is not really 600. This is 650 because this paper was torn and this 50 centimeters wasn't taken into account. If you don't have that issue when you were doing your trials, then don't worry about that. But this specific group would need to take into account these 50 centimeters that are here. I'm just going to do one more, and then I'll continue on showing you guys what else we need to do. So let's say I keep moving the ball. Let's say now it's at 350. So from the 600 mark to the 350 mark. So we have 100 centimeters, 200 centimeters, 250 centimeters, right? So that's 2.5 meters. And the time we just look at the time here, 1.52. So 1.52. So I'm just going to use these 4 points that we have so far just to show you what other things we need to do. And I'm going to zoom in a bit. So right here, this time is 0.87, right? Because this is our starting time, this is going to be our new 0. So we need to change this to 0 right here because that's our starting point. And all the other times that we have here, we need to subtract 0.87. So all of these will have 0.87 being subtracted from that time that you have on the video. Because we want to leave everything as our 0, that 0.87, that's our starting point, so that's our 0 mark. And I'm just going to do this right here, 0.87. And then if you just put the equal sign in front and then press enter, it just subtracts it automatically for you. Equals, enter, equals, enter. So now we have the time how we want it to show up, right? Now we can calculate velocity. Velocity is just distance divided by time. And in this case, you have distance 0 / divided by time. It's going to give us an error because we can't divide by 0, right? So we can just put 0 on there. But on the other ones right here, this one, we can't, right? 0.5 divided by 0.24. And that gives us a velocity of 2 meters per second. You guys can copy that formula or you can drag this down and it does it automatically for you. So this is your velocity of the ball as it's moving down. The more you fill out the table, the more the numbers are going to start showing up. We can do the same thing for acceleration. So in the case for acceleration, what we're going to do is we're going to put equals and we're going to multiply 2 times the distance that it travels. So whatever distance you have here, we're going to divide that by the square of time. So time to the second power. So we use power using this arrow facing upwards, and then we put A2. If we put enter, it's going to give us again an error because time is 0 right here. So don't worry about that. We can change it to 0. And then I'm just going to copy this equation that I use here, or this little formula, or here, I'll just do it here. This is going to be twice the distance. We have to use asterisks for multiplication. Twice the distance divided by time to the second power. So that's going to give me the acceleration. So the acceleration, if you notice, it should be close to 10 because 10 is the acceleration due to gravity. So this is approximately 10 meters per second squared. Regardless of the object falling, it should always be 10 meters per second squared. So we're only going to use this to compare the gravity the acceleration that we're showing on this portion right here. So this is the experimental acceleration. And there could be multiple things that are causing this to be slightly larger or slightly lower than the acceleration that we want to get to, which is around 10. The mass, I don't know what the mass of the object. This group is I think it's 50 grams. So that's going to be 0.50 kilograms, and that's just going to stay the same, right? Mass doesn't change unless a piece of the ball gets torn off or something. The force is going to be gravity multiplied by the mass. And this is the weight of the object. So it weighs 5 newtons, and then we can just copy this. That's not going to change. And that's pretty much it. In order to make your graphs, you're going to highlight the column for distance, highlight the column for time, insert chart, and then we'll change this to a line. So it should look like a curve. You guys will see this on the whiteboard. You'll see 3 different graphs with an asterisk and it says lab. The first one should look like a curve, and this is more or less already looking like a curve. Remember, you have to define your x-axis. In this case, it's time, and then we get rid of time over here on the y-axis. So it looks like a curve just like that. For velocity versus time, you want to highlight the column for velocity and time. So I'm only highlighting these right here because it's the only data I have. You guys will highlight the entire thing. So you want to fill out that table at least with 10 points, right? So I'll highlight this right here, insert chart, and this should give us a linear equation. So it should give us a line. So right here I get rid of time. So it doesn't look like a straight line, but the more points you have on there, the more straight it will look like. So, and then we can analyze why this might not give us a straight line, but it should give you a straight line. So there's some groups that have a straight line for this one right here. And then lastly, for the acceleration, so we're just gonna highlight the time column and highlight the acceleration column. You don't have to highlight the 0 part because then it's gonna look weird. So you can just ignore the 0 part. So then insert chart. And we should get, this should look like a straight horizontal line for acceleration versus time. It should be a horizontal line with a slope of 0. But again, like it's not gonna, you're not gonna see that, right? Because there might be errors in our experiment, right? Or our calculations. So you won't see necessarily a straight horizontal line. And that's pretty much everything you have to do. Like all you have to do is just finish filling out the table right here for these data points for distance and time, and then make the graphs. And then we can use these graphs to make an analysis on how the two objects are moving, right? So we're comparing the velocity, the distance, and the acceleration for the smaller object or the lighter object that I gave you guys with the heavier object. And I hope this helps, guys.